Jai Hind students, welcome to my YouTube channel. Students, there is nothing more true in your life than taking your own decision. For it in turn will decide the course of your future. It will decide the course of your destiny. What I mean to say is, students, this is the correct time when you should decide about your future. What you are willing to do in your future, what your aims are, what you intend to do in your life. Once you set your aim, once you set your goal, then do the appropriate and desirable actions so as to realize your goals and dreams. So students, with that, let's begin this session. As I promised in the previous lecture, I'll come up with some fresh set of numericals based on relative motion and relative velocity, right? So in continuation with that, we will discuss in this session these following numericals, which are based on river, boat and rain umbrella situations, right? So let's start with the first question, students. First question is, a boatman can row with a speed of 10 km per hour in still water. If the river flows steadily at 5 km per hour, in which direction should the boatman row in order to reach a point directly opposite on the other side? Right? So the situation is, as I told you students, in physics, you need to draw the diagram wherever applicable. It makes the numerical that much more simpler, right? Try to visualize everything. So as per this question, this is suppose the river and this is the river suppose, and this is the point where the person starts, right? And the river flows steadily at 5 km per hour. The velocity of the river is 5 km per hour. It's given. A boatman can row with speed of 10 km per hour in still water. That is, when the river doesn't flow, it is still, then the boatman can row with a speed of 10 km per hour. Right? Now, the boatman intends to reach a point directly opposite to the point from where he started. Means he intends to reach at this particular point, say point A. So the intention of the boatman is to reach point A, which is exactly opposite to the point where he started, on the other side of that of the river. Clear, students? Now imagine if the boatman starts rowing his boat along the direction OA, then what would happen? He will move along the direction OA and the river is flowing along this direction. So what will be the resultant of these two? These two will be the adjacent sides of the parallelogram and the resultant will be given by the diagonal of the parallelogram. So the boatman, if he rows along the direction OA, he will never be able to reach point A because of the velocity of the river. So as a result, instead of reaching point A, he will reach at a point somewhere over here. Clear, students? Because of the flow of the river. So now, if he actually intends to reach point A, he should move in a direction somewhat over here, so that the resultant of this velocity and the velocity of the river, that is along the direction OA, which in this case will make the boatman to reach exactly at point A. Clear, students? So he shouldn't row along this direction. Instead, he should row along this direction. Suppose this is the velocity of the boatman, which is given to be 10 km per hour, right? And let us consider it makes angle alpha with OA. Now with these two vectors, we can draw the parallelogram. As we are aware, students, parallelogram law of vector addition, if the two vectors acting at a point simultaneously be represented by the two adjacent sides of a parallelogram, then the vector resultant both in magnitude and direction is given by the diagonal of the parallelogram passing through the same point. So these are the two velocities. So the resultant must be along OA. So this will be the resultant. This will be the resultant. This is V. V is the resultant. So you can complete the parallelogram like this. This is the parallelogram. Clear, students? So river is flowing along this direction. The boatman is rowing his boat along this direction. So the resultant of these two would be along OA, so that it will enable the boatman to reach at point A, which is exactly the point O from where he started on the other bank of the river. Clear? So now what we are supposed to do is, we are supposed to find out the direction in which the boatman must row. Let's find out the value of alpha. So here, this is a parallelogram. So its magnitude is 5. So in a parallelogram, opposite sides are equal and parallel. So its magnitude must be also 5. Let us say it to be B. So it is also 5 units, and this hypotenuse is 10 units. So what to do is, in triangle OAB, obviously it's a right angled triangle. Consider we are aware of this AB, which is perpendicular, and this is the hypotenuse, right? So what we do is, let's consider sine alpha. So it will be equal to perpendicular by hypotenuse. Perpendicular is AB and hypotenuse is OB. So the magnitude of AB is 5 units. The magnitude of OB is 10 units, right? Both are representing velocity. So 5 by 10 would be a dimensionless quantity. Numerator, denominator, both should be having same units. So what do you get? Sine alpha is equal to half, which implies that alpha is equal to 30 degrees. Sine 30 is equal to half. So the boatman must row at an angle of 30 degrees with the direction OA, right? Or in other words, this angle is 90 degrees. So what will be the entire angle? It will be 90 plus 30. That will be 120 degrees. So the boatman must row in a direction which is at an angle of 120 degrees with the direction of flow of water, right? So boatman must row in a direction 120 degree with the flow of water. So the direction in which the water in the river flows, the boatman should row in a direction making an angle of 120 degree with the direction of flow of river. So in that case only he will be able to reach point A, which is exactly point O from where he started, right? So in such questions, students, you need to draw the appropriate diagram. After drawing the appropriate diagram, the question becomes very simple, right? Okay, so we are done with question number 1. Let's proceed to question number 2 then. Question 2, it's a rain umbrella question. On a certain day, rain was falling vertically with a speed of 30 meters per second. If wind starts blowing with a speed of 10 meters per second in a direction from north to south, find the direction in which a boy should hold his umbrella in order to protect himself from rain. Right? So it's again a very, very interesting question. Now students, look. Rain is falling vertically downwards and the wind is blowing with a speed of 10 meters per second in the direction from north to south. Now you can represent direction like this: north, south, west, east. But if I represent the geographical north, south, west, east in such a manner, then it would be impossible for me to denote the vertical direction, isn't it? What I mean to say is that in such questions where the vertical direction also needs to be represented, you need to try to draw three-dimensional diagram. So the appropriate diagram should be like this. This is suppose north, this is south, this is west, this is east. All are mutually perpendicular to each other, and this is the vertical direction. This is the vertical direction. I think in such cases this diagram is more relevant, isn't it? So let's read the question once again. On a certain day, rain was falling vertically with a speed of 30 meters per second. Let us represent all the vectors at point 2. So rain is falling vertically, obviously in the downward direction, and this is the speed of rain. It is given to be 30 meters per second. Fine, students? Okay. If the wind starts going with a speed of 10 meters per second in a direction from north to south, so wind is blowing along this direction with speed of 10 meters per second, like this. This is the velocity of wind. It is given to be 10 meters per second. So what's the angle? It is 90 degrees, obviously, right? Find the direction in which a boy should hold his umbrella in order to protect himself from rain. Now student, look, the boy must hold his umbrella in a direction in which the resultant of these two forces act. Only in that situation he will be able to save himself from getting wet, isn't it? So we need to find out the resultant of the rain and the wind, right? So obviously these are the two vectors representing the two adjacent sides of a parallelogram. So the vector resultant, both in magnitude and direction, will be given by the diagonal of the parallelogram passing through the same point. So let's consider the parallelogram first. So this is the parallelogram. In a parallelogram, the opposite sides are equal and parallel. So the resultant of VW and VR at point O would be like this. This is the resultant. Suppose it is V. V is the resultant, right? Let's consider the resultant makes an angle alpha with the vertical, right? This is the vertical. So alpha needs to be found. So alpha is the angle which the boy must hold his umbrella with the vertical towards north, right? So you need to find out the value of alpha. Now in a parallelogram, opposite sides are equal and parallel. So if it is 10 units, the opposite side must be also 10 units. So in this triangle, perpendicular is known to us, base is known to us, isn't it? So consider tan alpha. It is perpendicular by base. So it is 10 divided by 30. Again, both numerator and denominator must be of the same units, right? So tan alpha, it is equal to 1 by 3, which in turn is equal to 0.33. So its value can be easily determined, right? So it is equal to about 18 degree 26 minutes. You can check it in the trigonometric table, right? In case trigonometric table is not available, you can write it your answer as alpha is equal to tan inverse 1 by 3. That is perfectly okay. So basically, the boy must hold his umbrella at an angle of 18 degree 26 minutes with the vertical towards north. It is only in that case he will be able to save himself from getting wet. So I will extend the diagram, right? I will try to elaborate it. It should be like this. This is the umbrella. This is, suppose, the umbrella. And he must hold the umbrella along this direction. So this is the umbrella, and he must hold his umbrella in such a direction so as to make an angle of 18 degree 26 minutes with the vertical towards north. So this is the angle which the umbrella should make with vertical towards north. So this is the complete answer. So I hope students you are able to understand this, right? So in case in the same question, if you were asked to find out the resultant velocity, that would have also been easily done. The magnitude of the resultant would have been equal to square root of 10 square plus 30 square, because these two are perpendicular to each other. So the net effective velocity with which the raindrop strikes the umbrella would have been square root of VW square plus VR square. Clear? It's not asked in the question, but still, just for your reference, it can be easily done, right? Okay, so we are over with question 2 as well. Let's proceed to question number 3 then. Question number 3 is, a man is traveling at 10.8 km per hour in a topless car. I mean, the roof of the car is not present. It's totally vacant, or it's a topless car on a rainy day. He holds an umbrella at an angle of 37 degrees to the vertical to protect himself from the rain, which is falling vertically downwards. What must be the velocity of the rain? And it is given cos 37 degrees is equal to 4 by 5, right? So let's draw the appropriate diagram. And first, man is traveling with a speed of 10.8 km per hour in a car. So what is the speed of the car? It is 10.8 km per hour. Don't forget to convert the values in one system, and we prefer SI system. So let's convert it into SI. So 10.8 multiplied by 5 by 18. It will be in meter per second, isn't it? 18.6. So it will be 0.6 into 5. So it will be equal to 3 meter per second. So 10.8 km per hour is equivalent to 3 meter per second, right? Now let's try to understand the question. Okay, he holds his umbrella at an angle of 37 degrees to the vertical. So it's like this. This is the vertical direction, and the rain is falling vertically downward. This is, suppose, the velocity of the rain, right? It's falling in the vertical downward direction. And man is traveling at 10.8 km per hour in a topless car on a rainy day. Obviously, he'll be moving along a road on a level ground, so it will be like this. This is the velocity of the car, and it is given to be 3 meter per second. And he protects, in order to protect himself from rain, he holds his umbrella at an angle of 37 degrees to the vertical, right? It can be represented like this as well. Look, rain is falling along this direction and car is moving along this direction, isn't it? It can be drawn in this particular manner as well. So in this case, he holds his umbrella along the direction of the resultant of these two. So this must be the resultant. Clear, students? So you can complete the parallelogram. And with the vertical, it makes an angle of 37 degrees. This angle is given to be 37 degrees. This is how it is holding the umbrella. This is, suppose, the umbrella, and is holding, making an angle of 37 degrees with the vertical. Clear? Now what we intend to do is, we are supposed to find out the velocity of the rain. VR is to be obtained. Now this is a parallelogram, isn't it? So opposite sides must be equal. So it should be of 3 units. This is O, this is A, and suppose this is B. It's a right angle triangle. So in triangle OAB, it's given cos 37 degrees. It's given to be 4 by 5. Right? So therefore, we need to find out this. So therefore, what will be the Pythagorean triplet? Cos 37 is base over hypotenuse. It is base 4 units and hypotenuse is 5 units. From the given information, we can easily extract this numerical values, isn't it? Now, we have obtained the value of velocity of the rain. So what do we get? VR, it is equal to 4 meter per second. So the velocity of the rain with which it is falling in the downward direction must be 4 meter per second. So students, it was a very simple question. Simply you need to draw the appropriate diagram. There was nothing new in this question. Right, students? Okay, let's try the next one, fourth one. That's pretty important one. Fourth question, students. It's again a boat river question. A river 1 kilometer wide. Fourth one. A river is given and its width is given to be 1 kilometer, that is 1000 meter, right? Is flowing at 3 kilometer per hour. Okay, this is point O. It is flowing at 3 kilometer per hour. That's the velocity of the river. A swimmer's velocity in still water is 4 kilometer per hour, can swim only for 15 minutes. So the maximum time for which the swimmer can swim in water is 15 minutes. So maximum time is 15 minutes, which will be equal to 15 by 60 hour. So it is equal to 1 by 4 hour. Maximum time for which the swimmer can remain in water is 1 by 4 hour. It is the time during which he can swim, right? And his speed in the still water is 4 kilometer. Speed of swimmer. It is 4 kilometer per hour. Therefore, maximum distance which he can cover, which he can swim, right, in maximum of 15 minutes. That will be given by speed into time. That is 4 kilometer per hour multiplied by 1 by 4. That is 1 kilometer. So students, what we have extracted from the question is the maximum distance the swimmer can swim is 1 kilometer. So as a result, the width of the river is given to be 1 kilometer. Therefore, maximum distance he can swim is 1 kilometer. For that, he needs to swim exactly making an angle of 90 degrees with the flow of river. That is in a perpendicular direction. Isn't it? It is only then he will be able to reach the other side. Isn't it? So, in what direction should he strike out so as to reach the opposite bank? So, what should be the direction? He should swim in a direction making an angle of 90 degrees with the flow of river. Isn't it? It is only then that he can cover a maximum distance of 1 hour, a maximum distance of 1 kilometer in 1 by 4 hour. So, first part is over. He must swim at an angle of 90 degrees in the direction of flow of water in the river. Okay. What total distance will he swim? That's an important question. Suppose this is point A. This is the velocity of the swimmer, which is given to be 4 kilometer per hour. Right? It is given to be 4 kilometer per hour. It is given. Now, what will be the resultant velocity? This is the velocity of the swimmer in still water. So, when he swims in a river which is itself flowing in a particular direction, then its resultant velocity would be given by this, the diagonal of the parallelogram. This will be the resultant one. These are VR, that is the velocity of the river, and the velocity of the swimmer in the still water. It can be considered to be the two adjacent sides of a parallelogram. So, the vector resultant would be given by the diagonal of the parallelogram passing through the same point, isn't it? So, let us complete the diagram. So, this is a parallelogram. Right, students? So, suppose this is OA and let us consider this to be B. So, we can easily find out the resultant. What will be the magnitude of the resultant velocity with which he covers the distance OB? That can be found by using analytical treatment of parallelogram law of vector addition. Look students, whenever the two vectors are right angles to each other, then the resultant is always given by square root of a square plus b square. These are the two vectors which are at right angle to each other. So the resultant would be along OB and it will be given by, in magnitude, it will be given by Vs square plus Vr square. That would be equal to 4 square plus 3 square, which will be equal to 25. It will be equal to 5 kilometer per hour. So the resultant speed of the swimmer would be 5 kilometer per hour. Clear? Now what is the distance he will swim? This is the distance he will swim. OB is the distance which he will swim. Now OB, it is the distance. It will be equal to speed multiplied by time. What is the speed? What is the velocity along the direction OB? It is V, which is 5 km per hour, right? So distance would be equal to velocity multiplied by time. What time he is taking to reach from O to B? Again, maximum time of 1 by 4. So it is 1 by 4. So that is 5 by 4 kilometer. Clear, students? So it will be equal to 1.25 kilometer. So this is the distance travelled by the swimmer in this case. Right, students? Point to be noted is that in case of still water, you would have covered the distance OA in maximum time of 1 by 4 hours. But since river, that is water, is also flowing in a particular direction, therefore he must swim with the resultant velocity along this direction OB, again taking maximum time of 1 by 4 hours. So in order to calculate this displacement OB, we need to consider the velocity along direction OB and the maximum time which the swimmer can swim, that is 1 by 4 hours. So we found it to be 1.25 kilometer, right? That's the distance the swimmer will cover in the maximum available time, that is 1 by 4 hours. So students, we are over with question number 4 as well, right? Now question number 5, again it's a boat river question, very important one. Okay, question is, a man can swim with a speed of 4 km per hour in still water. How long does it take to cross a river 1 km wide if the river flows steadily at 3 km per hour? And he makes his strokes normal to the river current. How far down the river does he go when he reaches the other bank? It's again a question which is similar to that of fourth one, right? Let's proceed. This is a river and its width, I think its width is given to be 1 kilometer. The width of this river is given to be 1 kilometer. This is it. 1 kilometer or 1000 meter, right? Suppose this is point 2 and a man swims with the speed of 4 km per hour in still water, and we are supposed to take the time to cross 1 km wide if the river flows steadily at 3 km per hour. This is given to be 3 km per hour. This is the velocity of the river, right? And the man is swimming with a velocity of 4 km per hour in still water, and he makes his strokes normal to the river. Now normal means perpendicular to the river current. This is the direction of the river current, so perpendicular to the river current. It will be like this. Make an angle of 90 degrees. So this is the velocity of the swimmer, and it is given to be 4 km per hour. It is 4 km per hour. Clear, students? So we can consider these two to be the adjacent sides of a parallelogram. Suppose this is A and let us consider this to be B. So we can complete the diagonal, or we can complete the parallelogram and complete this diagram, right? This is the resultant. This is the resultant. So students, river current is along this direction and is making strokes normal to the direction of the river current. So obviously he will move with the resultant this velocity along this direction. Suppose it is point C. So actually he will be moving along direction OC. So let's find out the resultant velocity, right? Let's find out the resultant velocity. Just as was done in the previous question, here this resultant would be because of these two perpendicular vectors. And whenever the two vectors are mutually perpendicular to each other, then the magnitude of the resultant is given by square root of, in this case it will be Vs square plus V. So students, let's substitute the values over here. So what you get is Vs, it's 4, VR is 3. So we get square root of 16 plus 9. That would be equal to square root of 25, which will give us 5 km per hour. So students, the net velocity with which the swimmer will move along the direction OC would be 5 km per hour. Am I clear, students? Now we are supposed to find out the distance covered by the swimmer down the river. That is, this distance needs to be evaluated. Right? Now here I must mention a very important point. The time taken by the swimmer to reach from O to A, right, or to reach from O to C must be constant, because students, if in still water the person is moving along this direction, then the time taken by him would be given by distance, that is 1 km divided by 4 km per hour, which will be his speed in still water, right? But in case river current is also there, then he must move with this resultant velocity. In that case, its resultant velocity increases. But in this case, the distance travelled by him also increases, so that the time remains constant. Right? So what I mean to say is that time taken by the person to cross the river, it will be given by, if you consider direction OA, then this distance OA will be covered by velocity Vs. If you consider the distance OC, it will be covered by distance V, which is the resultant velocity. Clear, students? So if you substitute the values over here, we get T is equal to OA. What is the distance? It is 1. Divided by, it is covered with 4. And OC, we are not aware of this distance. And with what velocity the distance OC is covered? With 5 km per hour. So students, the key point in this question is always remember the time taken by the swimmer to travel from O to A with velocity 4 km per hour must be exactly equal to the time taken by the swimmer to travel distance OC with effective velocity of 5 km per hour. Why is it so? Because on covering lesser distance, its velocity is also less, so that the ratio remains constant. Here what happens is the distance increases, the magnitude of the velocity also increases, so that it compensates. So in both the cases, the time taken by the swimmer is constant. Right? And one more important point. Now that velocity is to be considered, which is along the direction of the displacement. If you are considering OC, then distance OC is covered with velocity 5 km per hour. Distance OA is covered with velocity of 4 km per hour. Distance AC will be covered with velocity of 3 km per hour. So the direction of velocity and displacement must be same. That velocity would be effective, which is along the direction of the displacement under consideration. Clear, students? So net distance covered would be OC is equal to 5 by 4. So it is equal to 1.25 kilometer. So that is the actual distance covered by the swimmer while traveling along OA. Obviously, due to this velocity and the river current, he will tend to follow this path, and he will actually cover a distance OC, which is 1.25 kilometer, right? So students, if I redraw this diagram over here, this is A, this is C, and this is O. This distance is 1 kilometer. This distance is found to be 1.25 kilometer. So this distance can be easily evaluated using Pythagoras theorem. And this is the distance which we need to find. It is the distance which the man covers down the river on the other side of the bank. Clear, students? So you can easily solve it. There is some other alternative method as well, right? That I will share it with you. Now, as I have told, the time taken by the swimmer in crossing the river, either following OA or OC path, is 1 by 4 hours. This is the time taken. Therefore, distance AC, if you consider this distance, it will be covered with velocity 3 km per hour and distance is speed in time. So 3 into in what time the swimmer will cover distance AC? In time 1 by 4. So it will be equal to 3 by 4 kilometer, that is 0.75 kilometer. Just use Pythagoras theorem and get the value of AC. It should be in agreement with this value obtained, that is 0.75 kilometer or 750 meter. So again I repeat students, the most essence of this question lies in the very fact that the time taken by the swimmer to cover distance OA with velocity 4 km per hour, it should be exactly equal to the time taken by him to cover distance OC with effective velocity of 5 km per hour. And second point is, the body will cover distance OC with the velocity along this direction, that is 5. The body will cover distance OA with velocity along this direction, which is 4. The body will cover distance AC in the same time with velocity along this direction, which is 3 km per hour. Clear students? So these are the two very, very important facts which you need to remember while solving questions based on boat river questions, right? So I hope you have understood the concepts involved in these questions, and that's it for this particular session. Do join me in my next lecture. Till then, do take very good care of yourself and stay blessed. Thank you.